Welcome back to ISOMath. Today we're going to talk about the chain rule and how we use shortcut derivatives utilizing the chain rule. Let's get started. The chain rule is utilized when we have composition of functions. When we have something such as f of g, also can be written in other notations such as that, and we need to find the derivative, and again it's a composition function. We have a function inside of a function. So let's take a look at it. It's a rate of change of a composite function. Rate of change of the outside function times the rate of change of the inside function. Here it is in Leibniz notation, dy dx equals dy dz times dz dx. But what that really means is probably easier to see here. Basically, if you have a composition of functions, f of g of x, that you're going to take f prime, the derivative of the outside function, and the inside function as it is, times the rate of change of the inside function. Or a little quicker, easier notation, simply f of g, its derivative is f prime g times g prime. So here's an example. What you want to do, again, hop on your airplane, go 10,000 feet in the air, and look down at this and see what you got going on. What you can clearly, hopefully see is that you got a function inside of a function, meaning you have some outside function and some inside function inside of it. And that would be, in this case, the f piece. Your f piece would be something raised to, some inside function raised to the 60th power. While your inside function, which is here, g function, the inside component, is x cubed minus 5. And we know we're going to have to find the derivative of f and derivative of g. So let's go ahead and find what g prime is. Using the power rule, we know that to be 3x squared minus 0. And f prime, if you look at it, this is nothing more than a power rule. So I'm going to drop down that 60, keep whatever's inside there as it is, and reduce my power by 1. So now that I have my components, that's a 59, I have my components, I need to piece it together using f prime of g times g prime. Well, f prime is the 60 raised to the inside piece of 59. This g right here, that's my g, that's the original inside piece, that's going to be x cubed minus 5. And then I got to multiply by my g prime, and my g prime in this case is 3x squared. And yes, I can put that 3x squared out in front, so it could be actually end up being 180. If I simplify out, 180 x squared when I multiply by that 60 times x cubed minus 5 raised to the 59th power. And that will be my answer of the chain rule derivative of that particular piece. Let's try another one. So here I have the square root of the quantity 2x cubed plus 4x plus 3. Again, hop on that airplane, have a nice overlook at it, and find out, see the big picture. The big picture is, you can see you have a function. You have a function here inside of another function, which is a square root function. So essentially, I have, because this can be rewritten obviously as nothing more than 2x cubed plus 4x plus 3 raised to the 1/2 power using my laws of exponents. And now maybe you can see a little clearer that I have a function inside of a function. So my outside function is my f function. My outside function is that raising that baby to the 1/2. While my inside function is the inside piece, which is nothing more than 2x cubed plus 4x plus 3. And I need to find the derivative of both pieces. The inside, using my power and constant multiplier rule, is going to give me a 6x squared plus a 4. While here, my derivative is going to be dropping down that 1/2 and minus that by 1 gives me a negative 1/2. So I'm piecing it together using my chain rule. I know I have f prime of g times g prime. So this is going to be nothing more than 1/2 my f piece, which is 1/2. Oops, I'm sorry, negative 1/2. Negative to 1/2. Well, my g is right there. 2x cubed plus 4x plus 3. And my g prime is right there, is my quantity 6x squared plus 4. Make sure you keep parentheses out here. And yes, I can distribute that 1/2 and move this piece out in front, but essentially that is going to equate out to your derivative. You can simplify it better through practice. Now let's take a look at this other one. We've dealt with this earlier, actually, if you've gone through the exponential rules from earlier sections. And we started off with this, and this is nothing more than, if you're comfortable, that's nothing more than e to the u, with u in this case being a negative 1/5 x. So we need to find out u prime. U prime is going to be basically the negative 1/5, right? Because that's the leading coefficient of that guy. And according to my, if you remember the rules earlier, my e to the u, which is nothing more than a to the u, it's going to be that ln of e times e to the u times u prime. Well, and we know that ln of e is 1. This piece right here equals 1, so I got 1 times e to the u as it is, which in this case I'm going to e to the u is right there, the negative 1/5 x, and my u prime is negative 1/5. So this equals negative 1/5 e to the negative 1/5 x, and that will be your derivative utilizing the chain rule. Yes, you can go through and do it individually pieces, but that in this case I think it would be easier if you just know that that rule that we learned earlier was in fact the chain rule embedded into it. Now let's try another one. So this one, here we have the square root of e to the negative x over 7 plus 5. Again, hop on your airplane, you can hopefully see whenever you radicals, we need to get rid of radicals, and you can see that we're going to have a function inside of a function. So if I rewrite that negative x over 7 plus 5 raised to the 1/2 power, now you can see that my f is my outside function is going to be that quantity raised to 1/2, while my inside function is e to the negative x over 7 plus 5. F prime is going to be 1/2, drop that 1/2 in front and drop that top piece by 1, which gives me a negative 1/2. And my g prime, again, that's nothing more than the power rule essentially, and here I have my g prime. The derivative of 5 is 0, but the derivative of this guy is another chain rule. It's another chain rule, so we're going to have, again, long ways, ln of e times e to the negative x over 7 times u prime, which is a negative 1/7. Or simply, that becomes 1 obviously, so I got negative 1/7 e to the negative x over 7 for my g prime. So piecing it all together, using my notation there, I'm going to have 1/2, my final answer is going to be, let's change some colors on us so we see a little better, it's going to be 1/2, my inside piece, e to the negative x over 7 plus 5, raised to the negative 1/2, times my g prime, which is right here, negative 1/7 e to the negative x over 7. And yes, I can come out and make that a little prettier. That'll be negative 1/14 if I bring everything out in front. E to the negative x over 7 times e to the negative x over 7 plus 5 raised to the negative 1/2 power. So that would be the answer you probably see in the back of your book. So hope that helps. And remember, check back to ISO Math for all your math needs, and we hope to see you soon.